Neal and Jonathan to the stage for the workshop. Thank you very much.
No.
Okay.
You're waiting it?
Yep.
Do you want a mic on the?
I want this one.
Okay. Do you want a mic on the audio case or?
Yeah.
Yeah.
Okay. I'll stay around.
So I think what we're going to do is do this kind of interactive. But what we're basically going to be covering is building a...
Well, not this. I don't know what this is.
Yeah, hold on. Technical difficulties. Where's the HDMI cable?
It's,
There it is.
yep.
Plug that in.
Right.
You had it. So essentially what we're doing is using something called Kiwi. It's an image building software. It's used by Fedora and SUSE, a whole bunch of RPM distros. And maybe some non-RPM distros.
Yeah, I mean, it works for any RPM, Debian, Arch, or Alpine package management system.
Yeah, so we're going to be building an image that we can then take. It's got NVIDIA drivers baked in, some software baked in. You can use it to bake in anything you want into an image. It could be a live installer ISO. It could be a disk image that you literally just like DD into a disk and then boot up and have like a first start. So say you're a system administrator supporting your users. You want to have an image that you can load on their system. They get it on first boot. It asks them, hey, set up your user, do this, do that. That's what we're going to be doing here. And naturally, kind of tying into Neal's talk from earlier, the thing we're really showcasing here is that it's just got the NVIDIA drivers that we ship already baked in. We're
Right.
booting with secure boot. It's just kind of good to go out of the box for doing graphical things.
Right, so here I have this AlmaLinux Kitten descriptions that I made actually this morning. So yeah, you can tell that we worked hard. So at this initial setup is, well, we're just going to go to browse files because looking at it from the diff side is weird. So here we have basically this structure, and it kind of starts with this AlmaLinux Kitten Kiwi file, which basically has like the basic properties of this, and it's set up with all the fragments of this configuration that we're pulling in together. You can see some basic stuff like we're including core packages, we're including the AlmaLinux branding and things like that here. And then it's further broken down into components which have things like defined users, how we're going to set up, for example, live installs, because a live ISO is usually something people want to have. How do we make bootable disks? And then a bootable disk definition type. So in this case, we have this set up with Btrfs because in AlmaLinux Kitten, we have Btrfs support. This will be coming to the regular release with AlmaLinux 10.1. And yes, because Btrfs is awesome. Then we have all these things like platforms where we have a minimal disk image. We have cloud images for all the different cloud providers and some that you probably weren't using. But they're all here with different permutations. And again, it's basically more the same where you have like these disk definitions and then you have the package sets coming in from here. And repositories for kind of the obvious stuff like getting the Alma and EPEL and things like that. And then this root folder has files in it that get just copied into the final image and things like that. So that's just kind of like an overview of this setup. In the Kiwi documentation, there's actually there's a tutorial that kind of goes through like the basics of how you make a very simple definition. Like you can have definitions that are fairly small. I don't have any offhand right now that are AlmaLinux based to show you that's like small and whatever, but this particular definition is set up such that we can create disk images, cloud images, container images, WSDL images, and of course desktop images. And for this particular thing, we want to, I can't click because I can't actually see all the buttons over here because the resolution is different.
Yeah, we can't see the full screen on the laptop screen.
Yeah, so like part of the laptop screen's cut off. That's okay, we can deal. So for this, this laptop is actually installed with one of the images that was built with this. And part of that was so that we could have, let's go to system settings because I can't see, and go to about the system. And it has full recognition of the NVIDIA GPU in place. And then and all of it just kind of worked out of the box, including having this actually work with the HDMI port and stuff. And this is on KDE Plasma with Wayland. And because KDE Plasma is the best, it actually has things like all the HDR and fancy Wayland features that right now no other desktop on enterprise Linux has. So what we want to do here is actually show the creation of these images. And I'm going to go ahead and maximize this so that we can see. We're going to clear this.
Building the image it's a pretty quick process. It'll take, on this machine, which is quite fast, it'll just take a few minutes. But essentially it will trigger off in the background essentially a CH root install, I believe is what it does.
Yeah, it does a root to build it.
So, just however long it takes to go through and install the number of packages that you're installing, as if you were just doing like a system update or a system install or something like that. It's not really anything excessive at all. It's pretty quick. And as everybody probably gathered, the Kiwi definitions, it's just a bunch of XML files.
Yep.
I think there's some other formats it supports. But
Yeah, I mean, the XML format is, so the primary format is XML, but you can do things like TOML, JSON, or INI. Please don't use JSON. It's bad for human consumption, just don't do that. But the main value of using XML is that the Kiwi input format has a schema, and it can be validated before it runs any action. So if you fat finger something, you won't have to wait for the image to fail before it will tell you that something has gone wrong. It can tell you very early, you can go and fix it, and then continue onward for the rest of, to actually run the build. So in this case, I just cleared out all the working artifacts that I used to test to make sure that this worked this morning, because you don't really want to tempt fate too hard. So here we're gonna create,
see if you can zoom in on that shell.
that's what I'm trying to do. And, damn it.
What control and do?
There we go.
Yeah.
And then,
Yeah.
so here we are. This is zoomed up so hopefully you all can see it. And this is just me running this. So there's this wrapper script here. Before I actually run it, I want to just show what the wrapper script is. So this is something that I wrote so to make it easy to correctly set up with all the options, because the actual Kiwi command line is fairly long. You can see it's a lot of extra stuff here. I can actually, after we run it with this command, I'll also run it again just with the simple thing so you can see what that actually looks like. But this helper script, it kind of exists in this repo in one part so that I can type less stuff, but in the other parts that we can run this in CI to be able to reliably run this the same way both locally and remotely. So let's sudo s. And so we have this, and this is the command that we're going to run. And I'm going to add to the end of this, well, first of all, let me double check this. Help is,
We forgot to mention, we want this to kind of be interactive. If anybody has any questions, like as we go along,
please
holler,
ask them.
and we'll get you a microphone and answer those questions as we go. So does anybody have any questions so far?
Just want to validate what I want to say. It kind of just looks like Packer, but better.
Exactly.
Yeah. All right, so I started using this about 8 years ago because Packer annoyed the crap out of me.
Just gave up on Packer.
Yeah, giving up on Packer is the best thing you can do in your life. Because
So we use Packer to build the the AlmaLinux cloud images right now, and we're looking at replacing that pipeline with Kiwi as time goes on. Hopefully, starting with 10.1, and this is basically all of these definitions that have been written are kind of working towards that, and then we just threw the NVIDIA GPU stuff on top. But it'll be able to take over almost all of the AlmaLinux image building, with the exception of, I believe, the installer ISOs.
yes, so
Everything else it can take over
Yeah.
and have it all in one place. Right now, we've got like 4 different pipelines to do different image types. And with the way it works with XML definitions, we have the baseline definition file, and then we can just add pieces to it. This is what we want for Google Cloud. This is what we want for AWS. This is generic cloud, OpenStack, whatever. It makes it very easy to add on to it.
Right, and let's kick this off. So this is using the Kitten thing, and I'm using the profile for the desktop disk. So this will produce a disk image that you can actually write to another hard drive. And then on first boot, on the first time it boots up, it will go through the second stage install process, which will ask you about name, locale, username, locale, time zone, all that other fun stuff that normally you'd be asked during installation. And the idea here is that you can mass deploy this, and then you can either do pre-configuration using either an Anaconda add-on or Ansible or whatever you'd like to set it up afterwards, or you can have it do interactive setup. And these are configured for interactive setup. So when you boot them up, it'll go and do the thing. This laptop on another disk here, this guy, we've already done it, and we'll show it to you, that we can actually boot into the second environment. And this is also set up the same way with this image, and we can show you how you can see that this in fact matches what that one was, because there are certain things in there. While it's already set up and we've gone through the first boot stuff already, you can see that, for example, well, while this is installing, I might as well go ahead and show off some of these things that you can use to tell. In the component set where we have the boot Btrfs disk, this is where we define the partitioning layout and stuff like that. And you can see for the boot disk Btrfs, we have the system disk name and the disk label to be set to AlmaLinux. You could, of course, set this to whatever you like for your own images. But the idea here is that any disk that's created with this, you will be able to tell because these are set to these labels. This does have an interesting side effect. Because Linux is kind of dumb here, you can't really mount two of these at the same time on the same system, because things will get confused. There is some work on trying to mitigate this, like being able to, we now can, with the latest releases of Kiwi, take in like the reproducible builds value, source date epoch, and use it to create a seed to make sure every time the build is both reproducible, and if there are changes to the definitions, that each build will be unique within that change set. So like you'll have the same UUIDs and stuff like that. So there's a bunch of control mechanisms for making either reproducibility or uniqueness, depending on which spectrum of the things you want. By default, I think it makes unique random UUIDs, but you can make it be like, if you are in the reproducible build space and you want reproducible images, well, insofar as we can guarantee from the tools that we're running to actually construct the image, we can do our best to do that. So in this case, I think okay, so this one is doing stuff here. And what I'm going to do is I'm going to show what it looks like on the back of this. So outer disk build, image root log. And you can see this is the background, the debug log that's being written to a file. And you can see that it's actually installing stuff. And over here, you see this is just the plain state of things. If I added the -- debug flag that I deleted from the command line earlier, then it would also, this would actually be present over there in the output. But I wanted to show what it kind of looks like normally, so we did it this way. Yeah, and like this, if you've ever installed systems or run with Ansible or whatever, this starts looking very familiar because all it's really doing is just DNF install all the things.
Yay, CH roots.
Yes, roots are awesome. What is interesting though about this is, let's see if we can kind of, let's Control C this, and we will K-write the outer build image root log. Right, so I popped this up in Kwrite because I wanted to show something interesting here. So within this space here, you'll see that we actually go through two phases. One that's called Bootstrap, and then the other one which is System. And that's like, the two stages for Bootstrap is how Kiwi allows multi-distro setup. So when I was building these images this morning on my computer, I was using it from a Fedora system because my personal laptops all run Fedora, and I was building AlmaLinux images from there, and those resulting AlmaLinux images worked fine. Like everything applied correctly, policy-wise, whatever, because what we do is we bootstrap enough AlmaLinux to then run the rest to make the AlmaLinux system on there. So we kind of we kind of make it work somewhat like Packer in the sense that when in normal image build systems other than Kiwi or Packer, what winds up happening is you use the host tools on the host environment to create your target environment. The problem with that is that the host environment can influence the target environment. You can get some weird results from that. One consequence in the Red Hat family of distributions is that you can have broken SE Linux setups. Because SE Linux policy is based on what the running kernel has and the runtime environment. And there are specific ways to work around this, and Kiwi does implement them, but most image build tools don't. And that means that it gets very difficult to make sure that you have a relatively sane environment being built in it. The other part of it is, let's say you build something from AlmaLinux.
See if we're done.
Yeah, let's go see that. We are still not done yet. So say you're building something for like AlmaLinux 8 or 9, and then you're targeting AlmaLinux 10. Well, with AlmaLinux 8, the RPM directory where the RPM database is stored is different from 10. So like 8 and 9 have a different directory from 10. And if you didn't do the bootstrap thing and you just created the thing directly, AlmaLinux 10 would not have the RPM database in the right place in your image, and you wouldn't be able to see where what installed RPMs exist because the database is not there. So we solved this by bootstrapping enough of the target distribution to then actually install the target distribution correctly. And that results in a lot of those things being erased. It's not a completely solved problem, but it's pretty close. We also have another thing that you can use as part of this if you want to have one for one, like your host operating environment and your target operating environment are the same. One way to do this is use a build system like, for example, Koji or the OpenSUSE build service, OBS, and then you can run Kiwi inside of that, and it will set up a root environment that is the target system and then build in there. The other way to do this is that we have a plugin called the box build plugin, which will set up a micro VM to do the environment, and it can be set up to, you can use custom micro VMs that match whatever environment you actually want to build things in. By default, it uses a universal box that's based on Fedora, but you can choose, for example, to produce an AlmaLinux box that it uses. And this is not the same box as a Vagrant box. It's a different thing. And it will use that as a way to run image builds in there. So you can see we're actually now at the last stage of this, the raw disk image. And this whole time that my mouth has been flapping has only been like, I don't know, 6 minutes? And
Yeah, you can't hear it, but the laptop finally cranked its fan up. It's finally doing something.
because it's compressing. And we do multi-threaded XZ compression, so we use all the cores. That's why it's finally spitting up. So once this image is created, I want to kind of take a dive into like some of these files. And again, while this is going on, please ask questions or whatever, because we're just kind of doing this interactively. Yeah?
Any more? Yeah. Microphone?
Microphone, dude.
Cross OS between, say, a D package and an RPM-based distro.
Yeah, so officially the upstream Kiwi project supports using the, only primarily supports the universal box for stuff. And the universal box is a specialized Fedora micro VM that has all the package managers included. So it has dpackage, it has apt, dpackage and apt, it has APK tools for Alpine stuff, it has Pacman for Arch Linux, and it has DNF and Zipper for the RPM distributions. And we have all the distro keyring packages installed, so like all the distro keyrings are available for being able to do it right. So we primarily recommend that you use the universal box, but we know that there are places where, like, maybe, for example, you were behind a proxy and you need special system configuration inside the machine to use proxies, or you are required to use specific distribution for your host environment. You can do all those things. There are caveats to all of them. One of the things that we used to say, and this is not true anymore with the very latest Debian and Ubuntu releases, but it used to be that you can't build RPM distribution images that work properly from Debian hosts because the RPM package in Debian was broken. This is no longer a problem, but it's still a problem in practice because most people aren't using the latest Debian. And so this remains broken for a bunch of people because they're using older stuff. Even worse so with Ubuntu because the people use LTS Ubuntu releases far beyond their expected lifespan, and that causes other problems. But generally, going cross-distro is fine. Caveat, though, like things like SE Linux, your host kernel needs to support. Everything that your target distro needs to have enabled. If it doesn't support it, then it will break.
That works and that's doable because a lot of people may not realize it, but if you're in Fedora, for example, you can DNF install apt or DNF install pacman and get those utilities because they're maintained by various people in Fedora specifically for things like this.
Yes. I, in fact, maintain the Debian toolchain and the Alpine toolchain and the SUSE
Pacman.
Yeah, and the SUSE toolchain specifically for using with Kiwi and Mekuzi, Make OSI from the systemd project. They both also use it, and so we have it in here so that Kiwi can be used that way. And upstream in Kiwi, we regularly test against Fedora to make sure all the different targets work. So we test the cross OS target pretty stringently. And I personally just don't do any development on anything else except for Fedora for even every other distro target. So that makes, I mean, at least from me as an upstream Kiwi developer, I consider it pretty supported. Okay,
We're good to go.
Yep, so these files are all done being made, so we're gonna go look at them. Control T and go to home.
We have a question.
All right.
Go for it.
Hello. Is it legal or illegal when companies ask people to or pay people to hack into their companies for good reasons or bad reasons to secure their bases or servers like that? I was looking on the internet, but I'm not really totally sure about that.
I'm not sure I understand the
Could
question.
you repeat that one more time?
When companies pay people to hack into their companies, is it illegal, legal, ethical, unethical? Like, is that a thing? Because I was just looking this up on the internet, or is it still an ongoing issue or a thing right now to make it more secure, their database and servers?
Do you understand the question? 'Cause I don't.
Yeah, I think we're a little bit out of scope. I think, if I'm understanding correctly, the question is it legal or illegal for companies to pay hackers to hack other companies? Am I understanding that right?
Something like that, but they ask people to pay people to do it to their own company to secure their own.
Oh, like pen testing?
Yeah.
Okay, pen testing, I'm not
Is
a
legal with the
lawyer, but that's...
legal with the contract.
Right, that's legal with the proper paperwork in order that it's...
If you're doing it without authorization, it's definitely illegal.
Right, but we're not lawyers.
Yeah.
But does that answer the question?
Yeah, pretty good.
Okay, yeah. As long as everybody involved is on board with it, as far as I know, that's a common practice.
Yeah, I mean, red teaming a business is a pretty common thing that a lot of security firms do, and they do it with the permission of those. A little out of scope of this, but yeah, that's...
Yeah, maybe not all of the engineers at the target company are in the know, but...
They probably aren't.
Somebody
will know.
is going to be in the know.
Somebody will know, but probably not you.
Yep, that's right.
All right, so now we have this, and I want to show some of these things off here. So one of the cool things about Kiwi as a tool is that it produces you output artifacts that tell you what's in it. You're probably familiar with SBOM, software bill of materials, and things like that. You can think of this as a proto-SBOM. It basically lists all the packages that were installed, and it shows the versions, the architecture, and the license tagged information. So like, for example, if you cared about, hey, I want to know anything that is GPL v3, right? So we'll just GPL 3.0. And I can see account service, Advaita cursor theme is LGPL, but sure, fine, whatever. And then you've got Akonadi and all these other things, right? So if you were wanting to figure out what packages follow a particular license, you could pull this up. Then you could import, this is a pipe-separated CSV file. So you can import this into any spreadsheet program and do filtering, mix match, whatever you'd like to do with it to figure out like what kind of queries you want to ask for it.
Compliance people everywhere rejoice.
Yes, pretty much. It was actually one of the killer features when I introduced it at the place I worked at like a decade ago, because not knowing what's in your images can really screw with you someday. The other part of this is kind of useful if you're a developer type or producing images and trying to track down bugs. If you keep all the images that you build and you have snapshots and you have checkpoints, neat thing is that these files are all sorted, but this file is special. This is all the change logs from all the packages that are inside your image. But since it's sorted, you can have 2 builds and then diff it. And then you will see only the changelog entries from packages that have changed. And this lets you very quickly pinpoint problems if you're encountering something. I have a good anecdote.
Or if you're looking for a CVE fix.
Or if you're looking for a fix, right. Yep. I have a good anecdote of when I was working on CentOS Stream 9 development, on the run-up to AlmaLinux 9, and I was working on some cloud image development for the company I worked for. I had discovered that between 3 days, my ability to SSH into the cloud images that I had been making stopped working. And I went and pulled those images because I kept copies of all of the generated artifacts. I had the package lists and I had the change logs. And so I could see what versions revved and what the changes were. And I saw that 2 things had happened. There was a small breakage in cloud init. It was a red herring. That turned out to not be the real problem. But it was another problem that I did wind up fixing. But the second one was there was a change in OpenSSH that made it so that it couldn't load the authorized key command that we were preloading into it. And it had changed in such a way that it needed a different permission bit and it needed an SELinux label. So, went back and fixed it, made some notes about it, and then it suddenly worked again. And these are the kinds of things that, like, when you have this extra information, you can very quickly pin down problems, or even like if you find that some new behavior, or you're trying to locate, if you're trying to prove that something has been fixed, having these sorted changes files and then being able to diff them can give you really nice information. Now, if you're building this inside of a build system like Koji, this data already existed in a different form in there. This is super nice because even if you're doing local builds or you're working in dumb CI/CD systems, like, for example, GitHub Actions or GitLab CI or Jenkins or any of those other things, and I mean dumb in the sense that they're not specialized, they don't know what you're actually building, and they don't have rich metadata about your task, then you have the information still and you can still work with it. This was one of the bigger flaws I had with dealing with Packer was there was no way for me to figure out what was actually changing between image to image because there was no record keeping within Packer for these things. Plus, you had to work off of a base image that you had no idea how it was changing. So, like, your levels of mystery meat were very high. So, not having mystery meat is great. I can tell you, knowing what meat's in the pie is good.
I like Vienna sausage.
Vienna sausage is good, but there you go. And then this last one is special in a particular way. This verified file is actually just. Oh, it's not zoomed enough? Ah, okay.
We got room, make it big.
Sure, there we go, very big.
Yeah.
So this one is the output of RPM-VA, which is verify all files that it knows about. And this tells you which files have been modified, and which files are totally different, and which files have been missing. In this sense, you can see that proc and sys are modified for some reason, and it's because Kiwi creates the whole directory hierarchy before it starts installing stuff because it needs to do bind mounts. So that confuses RPM a little bit, whatever. Etsy machine ID was modified because in our config.sh we zero it out so that every time when you boot the image, it'll generate a brand new one. The customizable types are SELinux labels because we have packages with SELinux policy, so stuff changes. But this initramfs one is because we have the NVIDIA kernel module that I talked about this morning preloaded in here. So all of the checksums changed because now this doesn't match a vanilla initramfs. And then, of course, we have this branding stuff that, like, we threw in I copied over the hacks from our Kickstarts to make the branding work. So there you go. And then you see the repo, AlmaLinux CRB repo, has also been modified, and that's because I turned on the CRB repo. It's not enabled by default yet. It will be, but for now it isn't. So it shows up as modified. This is extremely useful if you are trying to figure out mystery meat changes. Like, sometimes people will make changes to packaging, or especially if you have third-party vendor packages where they don't know how to document anything. They have magic scripts and stuff like that that'll do mystery meat stuff. This lets you see whether they've done any strange changes to the file system that you can kind of pick up. Because, like, for example, I had one security vendor gave me a package that I was required by our compliance team to install that the script had changed over time where it was starting to like disable other security services and drop in random files to change things or modify them on the fly in the install script. They didn't do it in the files themselves because they didn't want it to be obvious they were changing it, which I thought was pretty sketch. But it caught it in this, and I was able to revert them, which then I wound up having a yelling match with some of the people that made me have to ship this. And the end result was we stopped using that thing because it became hard to trust what was going on if they're doing mystery meat every time we get an update. So mystery meat, being able to decode when mystery meat is happening was pretty good from a security confidence point of view. And so that's one of the things I really like about this stuff. To date, I don't think I've ever seen any other image build tools produce content like this.
Not that I've seen, no.
And so now we have this disk image, and yeah, and that's basically what this is doing. So this one is actually a little bit different in that I actually told it to have an image release. So the way that you do these image builds is with this Kiwi command, this Kiwi build command. But let's run it by hand so that we can see what this looks like. And again, people can stop me if they have questions about stuff.
Any questions?
Because like, otherwise I'll just keep rambling and this will be very weird.
At least he said it out loud himself.
So what I'm going to do here is I'm going to actually just run the Kiwi command by itself rather than using my wrapper script and explain what options I'm using here. Obviously, Kiwi has a man page, like most reasonable projects do. That man page is also accessible from the documentation. Because I can't actually read any of this. Here we go. So these are the man pages in the web documentation form. Because this project was originally written in Perl and then rewritten into Python, the man pages follow Perl convention. So that means it's Kiwi : system : build because Perl modules. And someday I will fix this because I don't actually like this, but it's also more trouble than it's worth to fix, so I don't actually bother. But yeah, so you can find the man pages here. They're all listed under the working from command line section here. But I'm going to explain the commands that we're running here so that you get an idea of like why we're doing this wrapper. So obviously we're going to run the Kiwi command. And I want this time to have the debug output. So we're going to go ahead and do that. Let's see here. What does debug actually look like
We're
here?
at 40 minutes. We should boot the.
Well, we want to boot the thing now?
Soon. Yeah, soon.
Okay. Well, we can, we'll do that. So debug and stop being locked, type. In Kiwi, we have different image types. So OEM and ISO are the common ones, but OEM refers to just making a plain disk image, which also includes making virtual machine disk images. There's also WSL for WSL images, as well as OCI for container images that are for Docker, Podman, Kubernetes, and so on. There's a few other types, but those are the most important ones. So we'll do type OEM, profile, KDE, desktop, live, or not OEM, we'll do ISO this time. Profile, KDE, desktop, live, Kiwi file, AlmaLinux Kitten, color output because color is fun. Otherwise, it's just white and gray and bold, and it's just not so nice to look at. So nice colors. Description, and the description directory is here. Target dir, and we'll do output, outdir, build, outdir.
It's a lot of
Live.
arguments. This
Yeah.
is why you use a wrapper script.
Yeah, this is why. So now you're seeing like why the wrapper script exists is because this is a lot of stuff to type. And then I have to do this ISO generator thing. All right, let's figure this out. Let's see, distro build args. And this is scripts, AlmaLinux live ISO limit lab generator. The reason for this script, actually, we'll just poke this up real quick and I'll show you what this is for. So I have these scripts here to generate, oh, that actually probably just ran it and did nothing. So this is a script that I originally wrote for Fedora and copied it over here, which basically has a mapping of the Kiwi profiles to provide the volume labels and stuff like that, so that the label inside of the image is consistent and sane and fits under the vol ID limit of 32 characters. So, yeah. And we're just going to do that, and it will be AlmaLinux Kitten Live, and then image profile, KDE desktop live, and then -K. Is there any other things? Image release. Fuck it, we don't need that. We'll just go ahead and do that. And then, I can't type.
Enter our super secure root password,
Yeah.
sudo password.
Enter the fact that I apparently flubbed the command line. But anyway, I'm not gonna try to run this. This is too hard. I'm flubbing the typing too much, and I want to actually finish. So, but now you understand like why we have the wrapper script, is that there's a lot of options to pass, and it's easy to get them wrong because it cares about the order and the position of these parameters. So then we do this, and I do the thing where I have the, where's the image release thing? Okay, I'm going to do that. Image release, date, YMD. Of course, you can do whatever you actually want for this image release field. What this does is it gets appended to the produced image, and so it gives it a date stamp, and it makes checksums, and it'll create something called a Kiwi result JSON file, which you can see here in outdoor disk, or not. I guess it's not there, or maybe it was hidden. No. Anyway, so it'll create like a Kiwi result JSON file, and what you can use with that JSON file is you can have that consumed by automation to then take the correct files, verify them, and then publish them wherever you further want to go. This was originally created to support in the SUSE distribution family where Kiwi originally came from. It was used by the build service to be able to figure out what files needed to be plucked out and then pushed out into the mirror network. And Koji also uses this for being able to do the archiving that it uses for publishing the images for Fedora as well. So yeah, those are the things.
We probably don't have to wait on that to output.
No.
So anyway, what you'll have output from this is
And a live ISO in this case.
Okay, so this was a live ISO.
I already built the disk image.
Earlier we built a disk image that we could just DD straight to a disk.
Yep.
To make it super easy to, flash it to the disk, put the disk in the system, give it to a user, boot it up. So that's what we're going to do now. If you want to cancel that.
Yep.
We'll plug in our fresh drive here.
Yep.
That is literally just the image DD'd onto the disk. It's got the NVIDIA drivers baked into it, so we'll boot right up into it.
So let's go reboot into it now, or
Yep.
do you want me to DD it again?
No.
Okay, let's go.
Let's save that time.
Okay, we will save that time, and we will exit out of all the things because. And of course.
You can't see it.
No. It was working this morning.
There's a really cool Plymouth loading screen. That's the moose, moonwalking across the screen, but the HDMI output doesn't go active quick enough.
I saw it, it works.
So we saw it. It's really cool.
12. And then we want.
It's the Kingston one.
Yeah, it's the Realtek. It calls itself Realtek in this one.
Yep. Oh, that's right. Yeah.
I don't know why it has different meanings, but it calls itself Kingston to the operating system. It calls itself Realtek for the, I don't know. I give up. Computers.
It is doing stuff, the HDMI. If anybody's ever fiddled with a laptop with the NVIDIA Optimus stuff and external monitors, it's kind of a pain.
Oh man, we were
Good,
so
it
close to
came
showing.
alive.
Yeah. I mean, the moose showed up for like a split second.
Did it?
Yeah. So here we are, and this is now the other machine, and we can tell that this is so, because if I go look in here, nothing's there. All the stuff that we had was not there. And if we go into console, it has a completely different host name that I don't actually know where it came from, but hey, whatever. And importantly, if I do df-h, and if I do lsblk, you can see that this is a different layout from what we had on the in system we installed
Yeah.
from the live, because we have now a subvolume for var, and the volume name is AlmaLinux rather than, well,
Check the output of NVIDIA SMI.
and do we
So
have
let's
it?
make sure basically that our pre-installed NVIDIA stack is fine. Well, okay, we installed the driver stack, not NVIDIA SMI, so
Well, I wonder
we'll
if
install that real quick.
that's also how you know this is a different system. It's not there.
Right.
And so this image was created from Kiwi directly as a disk. And so what you could do is, Kiwi has a third mode of operation for install disks, is that you can make it create a wrapper ISO and a wrapper PXE image that you can then do to do network boot, network install, or mass install through DVD or USB sticks. And then it would just boot into it and start doing the thing. And so now we have this. And you can see NVIDIA
Well,
SMI.
the whole desktop is actually running through the GPU.
Yes.
Everything just worked out of the box. Secure boot is turned on this laptop.
We can actually prove that from about this system.
Oh, does that show secure boot?
It does over in one of these things, firmware security. Here we go. Here you go. You can see that we are in fact in secure boot, and we are actually all the way up to HSI 3, and we don't have encrypted RAM. And the Linux kernel is tainted because we have auto tree drivers.
Yep.
But there you go, everything else is working. So yeah, this is a full-on, fully provisioned system with working NVIDIA user space and kernel space from AlmaLinux Kitten on top of Btrfs, set up exactly the same way you would probably set up an actually good Fedora desktop. So like with KDE Plasma and all the things, this is basically derived from the same setup that we used for Fedora KDE's images.
Yeah, and this, of course, could be used for GNOME, with any customized package set you want. We just used AlmaLinux Kitten so that we could show Btrfs and KDE because
It's the best.
supports HDR. GNOME and EL10 cannot do HDR, at least not currently.
Yep. So because KDE's the best and Btrfs is awesome, that's why we picked these combinations. Or we could go with the more boring answers because it shows off the features that we actually have the best.
Yeah, and we're actually running out of time, but we benchmarked these drivers. This is, going back to Neal's talk from this morning, this is the NVIDIA Open drivers, and that is becoming NVIDIA, or it already has really become NVIDIA's main driver. The proprietary driver is kind of a thing of the past for the most part. New products are getting added to the open GPU driver. And historically, there's been a lot of concern of, is the open source driver going to perform like the proprietary? We did some benchmarking on this, as we have been throughout the whole development of these packages. And yeah, like this laptop's on the Blender benchmarks is in like the top 12% of results, right on par where its GPU should be. So the open GPU drivers perform excellent. Everything is rock solid, stable. So are there any questions about any of this?
So I do have a question. You've been using Kiwi for this image build. How does that compare to, say, the OS build, the rebuilt, was it Lorax Composer?
Yeah, so the question is basically about the difference between Kiwi versus Image Builder at this point, right? So for Image Builder imposes a higher degree of guardrails and constraints because it is formulated around this concept of declarative stages with predefined mutations. So predefined mutation in the sense of these are the certain types of actions we want you to be able to do inside of an image production pipeline. And this is for specifically optimized around the fact that Image Builder was first and foremost built for being run as an image building service in a multi-tenant environment. And so they wanted to have the design is such that it's around this idea of fully understanding the scope of changes that you're doing, and also being able to cheat when you know what the steps are gonna be. You can accelerate or modify the way that you do certain operations if you know exactly what the outputs are gonna be, and you can kind of skip ahead of some of the stuff. Kiwi is much more freeform. Like, we do have mostly declarative, just like Image Builder, but we have the get out of jail free card in the form of this config.sh script, which lets you put imperative steps that you may need that can't be defined elsewhere. This imperative step could even be just running an Ansible playbook if you really wanted it to be. So that's kind of the core difference between the two. I would probably say Image Builder is a lot better at simpler image types and image definitions, where you're not necessarily needing to go in and poke in at the details and do specific things to it, because you're basically trusting that the content set is already doing the right stuff. Whereas if you're building base distro images, or you're building things like, for example, custom branded images, you're probably stepping into the realm of there's a lot more power required to be able to pull that off, because you have to make more changes. And the upside/downside of the Image Builder approach is that in order to add more types of stages or be able to do more kinds of mutations, you have to modify the source code to be able to expose that functionality. And that's a mixture of Go and Python, and that's probably more than what most people expect to have to do to be able to define truly custom images. But it can be useful, and again, if you don't need to do all those things, then Image Builder is a perfectly serviceable option.
Anybody else? It can be about, questions can be about Kiwi or NVIDIA stuff or AlmaLinux in general.
Or KDE. I'm happy.
Yeah, really anything. We can take questions.
A bit of a side question on the Kiwi side. Building, say, an appliance image.
Yep.
Say you're building an industrial IoT type thing. Kiwi to build the image, and then a diff, build an image diff to upgrade, or what would you kind of see as the method?
You can do stuff like that. I mean, when I was working at a previous employer, we actually did do a variation of this. What we did was we would create the image, and then we would explode out the tree artifacts into a subvolume. And then we would basically update the subvolumes, and then we would do a send and receive to be able to update the machines with that new stuff. You can do that, and again, because Btrfs is now available through AlmaLinux Kitten and eventually in 10.1, you could implement that workflow. Another way to do this would be you can use one of the extra functions in Kiwi if you are more of the OCI-ish family of things. OS inside github.io/Kiwi. We have a thing about building images based on containers. So what you could do is use Kiwi to build a base container or base layouts or whatever, and then you can store it in a registry, and you can use what's called the stack build plugin to then consume that and use that as an input for producing more artifacts. So you create a stash based on a root tree that you have, and then you can pull the stash out and then finish it with it. Inside of Kiwi itself, while you do the Kiwi system build command, you're actually running like 3 stages all at once. You can actually run those stages independently. Stack build automates the separation of these steps by providing you an opinionated workflow for how to use this. You can use this with DDI style disk images if you're using systemd sysupdate. You could use this with your own custom mechanism. Like I know the Chromium OS people had this Cincinnati system, which used AB disk images with customized X4 volumes. And you can do basically whatever workflow you'd like in the embedded state, because Kiwi was originally made for building appliances and then expanded to do everything else. So like there's a lot of functionality about doing this, like even to the point of like being able to set custom initramfs arguments and seal them inside of the image for appliance building purposes. So you can do all those things with Kiwi if you so desire. It's just a matter of figuring out what kind of workflow you want and how you want to put the pieces together. Plus, Kiwi has a Python API, so you can use it to construct your own command line and interaction interface on top of it, using the pieces inside of it as a toolkit.
Thank you.
Anybody else?
Yep, guy over there. I'm gonna need a lot of water after this.
So I'm quite a big fan of Packer. I'm just gonna.
You're the
I don't know if that's
only one.
like a dirty secret. I'm just putting it out there in the room. But you sort of said why. You said you've moved to using this more than Packer.
Well, we're
So-
looking to within AlmaLinux. We're still using Packer.
So I've got two parts to my question. First one is kind of, could you talk through, if you can, kind of like the primary differences or what you see as the major advantages to Kiwi over Packer? And then the second part of that is, so from my perspective, I see a lot of the plugins available in Packer to be able to build, say, the cloud native images. What capabilities you have in Kiwi with that? Is it equivalent? I think I'd like to understand both of those two parts.
Okay, so the advantage of Kiwi over Packer is that it doesn't require a base image to work. For Packer to function, you basically need to boot up an existing environment, and then you make mutations to that runtime environment, you save it, and you export it. Kiwi works without having to do that, and this means a couple of things. First of all, it means that the build processes are faster because you are starting from nothing and you're just bootstrapping from a package management, and then you're sealing the rootfs tree into a file system. This is fundamentally faster than booting up a full operating system and then walking through the steps one by one and then checksumming them and then sealing them up at the end. The second thing about, your ask about like cloud native plugins and things like that, Kiwi doesn't need most of those because the requirement for those to exist for Packer comes from the fact that Packer does not let you define an image type. You cannot define what makes up an image. You cannot define what the contents of the image is. You cannot define the metadata of an image. That is all in the Packer plugins. In Kiwi, this is a combination of declarative and imperative information, and this can be defined within the thing itself. So like you make a disk image. Okay, you make a disk image. A disk image is a disk image. For a cloud provider, a disk image is a cloud image is just a disk image with either a custom file extension or not, with a bunch of files in it, with maybe some associated metadata attached to it at the end of the file. And these things are trivial for Kiwi to support, and thus they are. And that's why you can build for all the different cloud providers, even ones that don't exist yet, because oftentimes they're all just compatible with each other and they take similar metadata. And when you're talking about things like cloud native and whatever, Kiwi can run in any kind of environment that gives it the ability to work with loop devices. Packer, again, doesn't require loop devices because it self-boots up and then changes itself to then create the new image. But Kiwi, because it is creating a new environment inside of your existing one, you need to be able to provide loop devices. And this is essentially the only real requirement. And this makes it so that in a lot of containerized environments, it probably is not going to work unless you expose the dev loop subsystem and you have the ability to create loop nodes inside of the container. If you can do that and everything works, then you're good. Otherwise, you're probably not, and you want to use a micro VM or something else. The Kiwi Box plugin basically is what we upstream Kiwi to say is what we prefer you do if you need to have that kind of guarantee and you want to operate in a cloud native way, because it'll create a micro VM that does the thing and then it will quit and then be done with it. And note, with the micro VM, you only need dev KVM available, so in many cases you can operate that unprivileged.
Cool. What's the license of Kiwi?
It's GPL v3.
Okay, cool, thanks.
That's another benefit. It exists natively in the Fedora, Apple, in the ecosystem repositories natively. So it's a bit easier to get contributors involved in. They can more quickly make a change and quickly test that and spit out an image versus having to go grab repositories and figure out how to get Packer installed and fight against there's some system package named Packer that fights against it, and it drives me crazy every time.
Yeah. But yeah, like Fedora already uses Kiwi to build its images, and obviously OpenSUSE does because this is where the project came from. But yeah, so like there's a lot of familiarity in the community about using this and engaging with it, and it's very easy to ramp up compared to a lot of the other alternatives. I think the only one that might be as easy or maybe easier to get up and get started with is Image Builder, but that's because Image Builder is designed to provide a much simpler image building experience at the cost of some flexibility.
A lot of the ecosystem is kind of zeroing in on Kiwi, and assuming we adopt it, we'll actually be one of the later adopters. But it's nice having, more than just us working on it. Being able to collaborate with Fedora and CentOS and the rest of the EL and RPM ecosystem.
So I think that's it for us.
Yeah, we're about out. If there's one more quick question, we could probably take it.
Okay.
All right, cool.
And look, now you can see the moose.
Worse now, yeah, of course.